Okay, so this recording is going to be on determining the limiting reactant using the BSA table technique. And we did this in class, but this is just a way for you to do it again, see it again, pause me, go back, or speed me up. So this is the problem we went over in class. You're given starting amounts of each reactant. So I'm starting with 100 grams of sodium and 100 grams of the iron 3 oxide. When you're given starting amounts of both reactants, that's when you have to do a limiting reactant problem. And what that means is you need to figure out which one of the reactants is going to run out first. The one that runs out first, you're going to use it all up, and ultimately it will determine how much product you can make. So what if you have excess reactant of something else? If one thing runs out, you can't make product anymore. So that's the point of this limiting reactant thing, to figure out which reactant runs out first and to base the rest of your problem on that limiting reactant. So the first thing you need to do when you're given starting amounts of both reactants is you need to get those starting amounts to moles. You're not always going to be given grams. Sometimes you can be given a volume and a molarity. I don't think you'll be given atoms, but you may be given a pressure. Ultimately, we want to get everything in our BSA table to moles. So I'm going to take these starting grams of sodium and iron 3 oxide, and I'm going to convert them both to moles. So what I'm really doing is I'm just going to divide by the molar mass of sodium, and I'm going to divide by the molar mass of iron 3 oxide. Okay, and these molar masses here and here were just pulled off the periodic table. So these are my starting moles of sodium, and these are my starting moles of iron 3 oxide. And you're going to keep all of your several decimal places, so I would say at least 4 or 5 decimal places, and round at the very end. So don't worry about sig figs right now while you're doing your table. We'll worry about that at the end when we report a final answer. So you're going to make a BSA table on your paper. B is before, S is shift. That tells me which direction is this reaction going to go. And for right now, for stoichiometry, we're always going to make products. And then after, how much is left over in the reactant side, or how much product did I make on the product side? So I'm starting out with 4.3497 moles of sodium and 0.62617 moles of iron 3 oxide. And I just showed you that calculation. I don't have any moles of either product because I haven't made product yet. The reaction hasn't started. So I have to figure out what is my limiting reactant. So you need to do a need versus have assessment. So according to this balanced equation, I need 6 moles of sodium for every 1 mole of iron 3 oxide. So my ratio here that I need is 6 to 1. I'm going to put my larger coefficient on the top. Absolutely, you could flip this and put 1 to 6, that I need 1 mole of iron 3 oxide to 6 moles of sodium. But for me, it's easier to work with my bigger coefficient on top. So I need a 6 to 1 mole ratio. I don't know if I have that. I have a 4.3497 mole to 0.62617 mole ratio. So I have this. I need this. I'm going to simplify that ratio right there, and I'm going to get 6.9465. So that's this ratio simplified. So I actually have more than I need, and I'm comparing this to whatever reactant that I put on the top of my need ratio. So since I put sodium on top, I have more sodium than I need. So sodium is not going to be my limit. I have more than I need. Iron 3 oxide has to be my limit. Okay, so this reactant right here will be my limiting reactant. So I'm going to mark that. So sodium is my excess reactant. I'm going to have that left over at the end. whereas iron 3 oxide is my limiting reactant. I'm going to use all of that up, so I shouldn't have any left over at the end. If you accidentally mix this up and you made sodium your limit and iron 3 oxide your excess, once you do your table, you would end up with a negative answer down here for the after part of your reactant side. And right there you would know you can't have negative moles, so you would go back and you would switch what's your limit and what's your excess reactants were. But I'm telling you, from this ratio right here, since I have more sodium than I need, sodium is the excess and iron 3 oxide is the limit. Okay, so I'm going to work all of this problem off of that. All right, like I said, we don't have any moles of product, of either product to start out with. So before the reaction, I don't have any moles of product. For the shift, this tells me how much I'm going to increase in terms of moles or how much I'm going to decrease in terms of moles. So since I don't have any products, I'm going to go to the products. So I'm going to add to the product side, and the reactants are going to get reacted. So I'm going to use them up. I'm going to use the iron 3 oxide completely up, whereas the sodium, I'm going to have some of that left over. So I'm going to use up all of this limiting reactant, so I'm going to say minus the mole amount there, 0.62617. So at the end of the reaction, I shouldn't have any of that left over. For the sodium, I'm going to use up a ratio of 6 to 1 times the mole amount of iron 3 oxide that I have. I'm going to need 6 moles of sodium for every 1 mole of iron 3 oxide. So that's where my 6 to 1 ratio comes in. Okay? So I'm going to take my moles of iron 3 oxide and I'm going to multiply that times a ratio of 6 to 1. And when I do that, I'm going to get right here in green 3.75702 moles. That's how many moles of sodium I'm going to use. I started with 4.3497 moles. I'm going to use 3.75702 moles. So left over, I'll have 0.59268 moles left over at the end. Okay, now I need to figure out how much product I'm going to make. So if I look back up here at my balanced equation again, I can make 3 moles of sodium oxide for every 1 mole of iron 3 oxide I have. So that ratio is 3 to 1. Well, I have 0.62617 moles of iron 3 oxide that I can use, and I'm going to use all of that. So that will react to form sodium oxide in a 3 to 1 ratio. So I'm going to take my moles of iron 3 oxide and multiply that times 3 divided by 1. And then I'm going to do something similar for my iron. If I'm going to make iron, I can make 2 moles of iron for every 1 mole of iron 3 oxide present. So that's a 2 to 1 ratio. So right here, I can make iron in terms of the limiting reactant times the ratio of 2 to 1. Okay? So I'm going to multiply 3 times 0.62617, and I'm going to multiply 2 times 0.62617. I don't have any initial product that I'm starting out with, so once I get these answers here, I'm going to add those to 0, and I'll have my after. Okay, so I should be able to make 1.87851 moles of sodium oxide, and I should be able to make 1.25234 moles of iron. Okay, so then I go back to the original question, and there are steps in here. Okay, so first you need to figure out, well, what the limiting reactant is. So we've already done that. We said that the limiting reactant was the iron 3 oxide. And if you need clarification on that again, then stop me, rewind me, and go back. Second, they want to know what mass of solid iron is produced. Well, I don't know the mass of solid iron that is produced, but I do know the moles of iron that are produced. So this number right here is directly from the table. I'm going to go back and show you. Right here, this is the number of moles of iron that are produced. So I want to convert those moles of iron into grams of iron. So I need to multiply my moles of iron times the molar mass. And right here, where you start actually giving numerical answers, that's where you're going to report sig figs. Okay, so I need 4 sig figs since I had 4 to start with in the problem. So I can make 69.94 grams of iron. Next question. What's the mass of sodium oxide produced? Well, I don't know the mass of sodium oxide produced, but I do know the moles of sodium oxide that I made from the table. So I made 1.87851 moles of sodium oxide, and 1 mole of sodium oxide has a mass of 61.98 grams, and that's the molar mass of Na2O. So ultimately, I can make 116.4 grams of sodium oxide. So I'm just converting my moles of sodium oxide into grams of sodium oxide. And then the last question asks you what mass of your excess remains. So at the end of this, I have 0.59268 moles of sodium left over. And I can look back at the table and make sure that number is correct. Yep, right here. Okay, so I started with this amount of moles of sodium. I used this amount, so I have 0.59268 moles remaining. So all I need to do now is change those moles into grams. Okay, so I'm just going to multiply times the molar mass of sodium, and I should have 13.63 grams of sodium that remain. And so that's how you work a limiting reactant problem using a before, shift, after table. If I were you, I would be very comfortable with doing that, because not only do you have to do this on your free response, on your calculation part of a quiz or test, but you also have to do multiple choice stoichiometry where you don't have a calculator. Of course, you wouldn't have numbers that are like this. They'd be much closer to whole numbers, if not whole numbers. But the table is an awesome way to quickly show what the ratio of each chemical is to another, and relating that ratio to starting amounts of substances that you have. So if you have questions, ask me in class, but watch the video again to see if that will help you.